Hi, my name is Rubesh. I come from Hancock County, and my project is direct versus reverse verification. I wanted to see which verification would be stronger. So I made this bike, and before this project, I thought that reverse verification would be stronger. We use different ingredients and tools. The main ingredients are calcium lactate and sodium alginate. These two ingredients can make a liquid into spears. We used water, but you can also use any flavored drink too. And we used a syringe or a dropper to put the boba and put the liquid in and make the boba. And then we used this Lego Spike Prime so it can check the strength. So direct and reverse verification, how does it work? Direct verification, we put this is sodium alginate, this is calcium lactate. We put the sodium alginate in the calcium lactate. And then it's not exactly a sphere, but a solid shape comes out. And then reverse verification is basically the ingredients just reversed. So then it would be like this. Come on. The straw won't get much. So I guess I'll have to use this. So a solid shape comes out. These two, direct verification and reverse verification, since the food safe powders are reverse, they have different outcomes. Direct verification, the size stays the same, but the liquid amount gets smaller and smaller because the membrane is just the liquid, so the size doesn't expand. The size stays the same, but the liquid amount is getting very little by the time because the membrane is the liquid, and the liquid and the membrane, it just presses until there's no more liquid, and that's why the membrane has a taste. But for reverse verification, the bath, the bath is this type of like white liquid. For reverse verification, the bath is the membrane itself, so the liquid stays, but the membrane the liquid amount stays, but the membrane keeps on expanding until the membrane is fully all of the bath, and there is no more of the bath left. So it would give something like a jello. So we want after we made our boba, we let the boba sit for different amounts of times, 5, 10, 15, 20, 25, 30. And we put it in, I made this, and I'm just gonna use a marble as an example. Huh. Okay. So on this graph, the data comes and the strength is 10%. So we tested out with different bobas, and we had different results. And with the results, we had the data and we made a graph with it. And from this, we can draw a conclusion that reverse verification is stronger. That's because at these 2 points, reverse verification is stronger than the direct verification. Usually, direct verification, if it's 10, it means that it only sends a little bit. 10 is actually the lowest you can get. So that's why reverse verification that got 25 in 5 minutes is the strongest. When we did this experiment, we faced some problems. So we made sometimes the boba would move away. So we made some of these models. This was the first model. I made these models in Tinkercad and 3D printed them. We put it here, we placed the boba, but this wasn't really a good model because sometimes it would press the edges of the model. So then we made this model. It fits perfectly with that circle, and we can just place it in and it presses good. Even though it still comes out, it's still better. And sometimes when we made the reverse verification, it didn't come out in a circle like direct verification. Instead, it came out in like a line. So we froze the reverse verification liquid and put it in some circle-shaped mold and then we freezed it and put it in the vat. And there are some future work and potentials to this. The direct verification can be used as fertilizer because it's not fully closed in. The liquid actually still comes out while it looks closed. Liquid is still coming out, and that can be used as a fertilizer. It can also be used for medicine, like capsule medicines. So that's my experiment. My name is Matthew Pace. I'm 10 years old and I'm from Prentice County. Today I will demonstrate how surface tension works. Surface tension is the skin-like surface on top of all liquids. If you put a little bit of water in a clean plate, then add pepper flakes, you'll see that the pepper flakes are floating on top of the water. The reason the pepper flakes are floating is because the water molecules are so close together that they have no other choice than to bond together and help the pepper flakes float. If I put a little bit of dish soap on my finger, when I touch the water, all of the pepper flakes go to the sides. The reason pepper flakes go to the sides is because dish soap is a surfactant. All surfactants break the bond's water molecules. And when the bonds are broken from the water, of the pepper flakes go to the sides. The reason the soap is a surfactant is because when it's cleaning, it will break the surface tension of the water and help loop the water to clean stuff. Hello, my name is Nicholas Beckemeyer, and I live in Diamond Head, Mississippi, and belong to Hancock County 4-H program. Today I will be teaching you how to make invisible ink. You will need baking soda, water, turmeric, alcohol, paper, paintbrushes, measuring spoons, and 2 bowls. It's going to be a good idea to wear an apron and a tablecloth because the turmeric can stain. In 1 bowl, mix 1 teaspoon of baking soda. In 1 cup and 1/2 and half a cup of water. Then you're going to have to mix it until it makes a watery paste. And then you dip your brush, and then you can make any design that you want. I'm gonna make a smile. Next, 1 teaspoon of turmeric. And a tablespoon of rubbing alcohol. And then you need to stir it until it's watery. And then wait a few minutes for it to dry. And then you can use this. Well, you use this. You rub it over your picture, and then your picture will become red. And then you're finished.